Good morning. So we're back, starting new chapter, chapter 5, which is all about rational exponents and radical functions. So basically, we're going to be talking about exponents and roots. So 5.1 is talking about nth roots, kind of an introduction to how we're going to work with radicals and exponents. It's just like the other units, we're going to be, or other chapters, we're going to be graphing them, solving them, and learning some theorems and properties. So this is kind of our introduction. So we're going to start with a little simple intro, which right from the beginning of the chapter. X cubed equals 125. How would you find the real roots, right? So we're ignoring any imaginary numbers. So if we were to solve this, hopefully, I think we've done this before, the inverse of cubing a number would be to take the cube root of it, right? Because then we just end up with x, and we have to do that to both sides. So if I cube, or take the cube root of both sides, I end up with x equals 5, right? It can't be negative 5 because negative 5 times negative 5 times negative 5 is not going to give me positive 125. So that's one real root. Are there other real roots? So remember that this is a cubic function, so there are 3 roots. But let's figure out what the other 2 are. So remember the discriminant, b squared minus 4ac, and then you can look at that, right? And then if the discriminant is less than, let me find my notes. You should have this from your section. I was just looking this up. From chapter 2, I believe, when we were learning about. Was it chapter 3 when we were learning about? Should have marked it. Yeah, it was chapter 2. Chapter 2.6 when we were learning about quadratics. Remember the discriminant? If the discriminant is greater than 0, there's 2 real roots. If it equals 0, there's 1 real root. And if it's less than 0, there's 2 non-real roots. So let's just check that, what the discriminant is. So you might be like, okay, well, how am I going to find the discriminant of this function? So what we've just done is if we rewrote this as x cubed minus 125 equals 0, we've just found that one factor of that is x minus 5. Right? So now we need to find out what's remaining. So in order to do that, I can do long division or I can do synthetic division. I'm going to do synthetic division. So if I set that up over here, I have a coefficient of 1 in front of x cubed. I don't have an x squared. I don't have an x. And then I got minus 125. Right? So step 1, bring the 1 down. 1 times 5 is 5. 0 plus 5 is 5. 5 times 5 is 25. Add that up, it's 25. 25 times 5 is negative 125. What did I do wrong? I mean positive 125. Why am I writing negative 125? So that comes out to 0. I was like, wait, I shouldn't have a remainder. So what's left, my factor term, is x squared plus 5x plus 25. So now I can use this part here to evaluate the discriminant, right? So let's check it. B squared minus 4ac. That's going to be 5 squared minus 4 times 1 times 25. That comes out to be 25 minus 100, which is negative 75. So since the discriminant, this thing is less than 0, right? It's negative. It has 2 non-real roots. We know there are 3 roots. 2 of them are non-real, so the only real root is x equals 5. Okay, so just kind of tying what we learned in the past chapters to what we're going to study today. So then just some terminology. If we have the general format of x to the n equals c, this n is what you would say the nth root is, right? People say to the nth degree. And then if you were solving that, you would say that x equals the nth root of c, right? Kind of what we did here. And so just so we have our vocab right, the number under the radical is the radicand. And then this obviously is the radical symbol. Okay, now let's just use this to solve some problems. We'll start off easy. So sometimes, and you guys probably remember this from Algebra 1, you have numbers being raised to exponents that are fractions. So 16 to the 1/4 really just means the 4th root of 16, right? You can write them either way. So how are you going to find the 4th root of 16? Well, what number times itself 4 times will give you 16? 2, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. But also because this is a positive root, it could be positive or negative 2. Because I can multiply negative 2 4 times, and I would also get positive 16. What about when it's like this, 27 to the 2/3? So it's really, this means 27 squared all to the 1/3, right? So then that means we're finding the cube root of 27 squared. Actually, I want to rewrite this the other way because it makes it. So what I want to do actually is I want to rewrite this as the, because really this, what this means is 27 sorry, I shouldn't have written in pen. Like this. The cube root of 27 squared is much easier to solve, so I'm going to rewrite it like that. Cube root of 27 squared. Why am I doing that? Because I know the cube root of 27. What's the cube root of 27? It's 3. 3 times 3 times 3 gives me 27. So then that comes out to be 3 squared, which we know is 9. It can't be negative 3 because this is an odd root. All right, here, if you have a negative exponent, hopefully you remember that means it's at the bottom of a fraction. It's the denominator of a fraction. So let's just deal with this like we did that one. So we're going to say it's the cube root of 27, but now instead of being raised to the positive 2 power, we're going to say it's raised to the negative 2 power. So now if we deal with the inside, we know that that is 3 raised to the negative 2 power. And then that negative exponent means that it moves to the bottom of a fraction. And then we just have it as 1/9. Those are exponent rules, which you should have learned in algebra. We actually, it's kind of interesting because we go over those in the next section. We'll review the exponent rules. Okay, so those were just some applications of exponents. Now let's simplify some. So here we have the 5th root of 32 times m to the 15th. So really what I'm trying to do is see if I can find the 5th root of any of these numbers, okay? Because then I can take them out of the radical. So I know I can rewrite this as, I know the 5th root of 32 is 2. So I could rewrite that as 2 to the 5th if I wanted to. Because now I know I can take the 2 out. Okay, m to the 15th. Well, I want to be able to take some of those m's out. Well, let's do this first. Let's just do that step. So now what do I have? I can take the 2 out, right? Because the 5th root and the power cancel out. And I'm just left with the 5th root of m to the 15th. Okay, so I'm trying to find the 5th root of m to the 15th. So really, I could figure out, well, how many groups of 5 are in m to the 15th. So I know it's 3, so you could quickly think about it like that. Or if you wanted to, you could rewrite it like this. Because one of the rules of exponents is when you're multiplying bases that are the same, you can add the exponents. So 5 plus 5 plus 5 gives me 15. Really, if I wrote out 5 m's plus 5 more m's and 5 more m's, I would have 15. And really that helps me because now I know I have 3 groups of 5 that I can take out. So that's why it becomes 2m cubed. There are 3 groups of m I can take out. All right, what about this one? The 4th root of x to the 20th times y to the 8th. So again, I'm trying to see if I can get those groups of 4 out. So I can rewrite this as, I know I can rewrite this as 5 times 4 is 20, so what if I do this? Remember that rule of a power to a power is you multiply them. So this is really another way to write x to the 20th. And then if I want to get another power of 4 out here, I know I can write that as y squared to the 4th. Now I can take those directly out of the radical because that's going to the power and the x, or the radical and the exponent cancel out, so that's x to the fifth times y squared. All right, so this root is even, okay? So the solution has to be positive. So in order to make it positive, this term, y squared, is always going to be positive, but this x to the fifth has a chance to be negative. So to ensure it's positive, I have to put those absolute symbols, absolute value symbols around it. So that's one thing you're all going to have to be looking at this unit, like is the power or the radical even or odd, and how does that impact the solution, and what do I need to do to make sure that the sign is what it's originally started at. All right, now let's do some solving. 2x to the fifth equals 64. Okay, well, let's start with dividing by 2. So that means x to the fifth equals 32. Just divided by 2. Now to get rid of the fifth power, I'm going to take the fifth root of x to the fifth, and that equals the fifth root of 32. That comes out to be x, and x equals 2. It's definitely an answer. Can it be negative 2? So if I do negative 2 times negative 2 times negative 2 times negative 2 times negative 2, I would end up with a negative answer, right? And my answer has to be positive. So that's why only positive 2 is not an answer. So only positive 2 is an answer, sorry. Negative is not an answer. Like I said, you have to check and think about the reasonableness. All right, let's do this one. I actually wrote it down. It's from a story problem on page 243. So instead of drawing that picture, I'm going to just show it to you here. So it's actually example 6 in your book. It says, one cube-shaped container has an edge length 2 centimeters longer than the edge length of a second cube. Okay, so the side of this top cube is 2 centimeters longer than this one. The volume of this larger cube is 729 centimeters cubed, and then it empties into this small cube. So because this one is bigger than this bottom one, some of it has to spill over. And they're asking how much water will spill. Okay, so first, we need to compare the volumes, right? And then find the difference. So we know the volume of this is 729. And we know that the volume, or the edge length of this big cube, is 2 more than this bottom one. So if it's a cube, remember, if it's a cube, you find the volume by cubing the dimensions of the 3 sides. So what we're going to say is if this is side length x, this would have to be x plus 2, and each side would be x plus 2, right? Because they're all 2 centimeters longer than the bottom one. So really what they did to set up their volume equation is say each side, which is x plus 2, cubed equals 729. So that's where I've started here. Okay, so now let's solve it. So I need to get rid of this cubed. So we're going to take the cube root of all of this. We're going to take the cube root of 729. Okay, so this ends up being x plus 2 equals, well, cube root of 729 is 9. If you don't know all these, then you can do it on your calculator and check, it's fine. Then when you solve for that, you get x equals 7. Okay, what is x? Well, x is the dimension of the small cube, the side of the small cube. So now we know that the small cube is 7 by 7. Okay, so to find the volume of the small cube, we'll take that side length and cube it, which ends up being 343 centimeters cubed. Now remember the original volume they gave us of the big cube was 729 centimeters cubed. So if that much water is flowing into this smaller cube, some of it falls out. So what's the difference? 729 minus 343 ends up being 386 centimeters cubed of water will spill out. Okay, so that's all for our introduction. I'll see you next time when we review the rules of exponents.